How's it going, everyone? I'm Nick, and you're listening to the Fresh Perspective Podcast. Welcome to part 3 of our series on stargazing. In this episode, we will find the stars of Ursa Minor, the small bear, also known as the Little Dipper. Enjoy an alternative mythological origin of this constellation from the one shared in part 2, and learn how explorers, mariners, and pioneers have been able to use this constellation to find north for thousands of years. So download this episode, step outside, and listen along as we turn to the most northern constellation in the northern night sky. This program is brought to you by the members of the Free Thought Initiative. We help those in need of an inclusive, supportive, and free-thinking community by hosting public discussions on moral philosophy, healthy living, and science to improve the cohesion, health, and scientific literacy of our society. Everyone is welcome, regardless of personal religious belief, political leanings, etc., to participate in person in these open and civil discussions. To find a Free Thought Forum meeting near you, to start your own local group, or to become a member and support this program through monthly donations, please visit freethoughtforum.org. Whenever I picture the little bear in the sky, I like to imagine him as a polar bear cub who likes to swim. The white fur and newborn features, I think, represent the special place this constellation has in science and in history. First, let's find Ursa Minor. After that, we will take a look at each of the bright stars that constitute his shape. Finally, we will wrap this episode with a few stories about him and about our Earth's North Pole. By now, you can hopefully find the Big Dipper pretty easily, making up the back and tail of the Great Bear. Once you've spotted the Big Dipper, see if you can locate the two stars at the front of the bowl. Depending on the time of year, they may be pretty low or high in the sky, so it may take a moment. Now that you've spotted the two front stars of the bowl of the Big Dipper, you can use them to point the way. Trace a straight imaginary line from the bottom star, Merrick, up through the top one, Dubhe, and shoot off out of the bowl in that straight line until you hit the next bright star you see. That is how you find Polaris, the North Star. Since the High Middle Ages, travelers and explorers from Europe and the rest of the Northern Hemisphere have been using the exact same trick you just used to find north. It is a simple trick, but one that has made the difference between a safe return home and the tragedy of being lost at sea. If you don't have a compass, map, phone, or GPS, you will still always be able to find north as long as you can spot Merrick and Dubhe and trace them to Polaris. The Little Dipper is remarkably similar to the Big Dipper, and once you've found the North Star, you've found the tip of the Little Dipper's handle. From here, it should be easy to spot the next star of the handle, a third, and the 4 stars of the Little Dipper's bowl. Just like that, you have found Ursa Minor, the small bear. The stars of the small bear are pretty dim, so unless you are under a dark sky, you may only be able to find Polaris. Once you've had a moment to look over its shape, you may notice that the tail of the small bear is curved differently from the tail of the Great Bear. While the Big Dipper has a handle that is easy to hold, the Little Dipper's handle is curved the wrong way. It is fun to imagine why. Perhaps a small child got their hands on the Little Dipper only to bend it in a terrific feat of strength. I suppose their mother was not impressed. These constellations may look like they are motionless now, but throughout the night and throughout the seasons, the Big Bear is always circling around her cub. Although the mother may get tired and hang low in the horizon in the fall and winter, her cub is filled with energy and loves playing up in the sky. The Big Dipper and the Little Dipper have a yin-yang kind of positioning with respect to one another. They are never side by side, but rather look like one is pouring water into the other. Which one is higher for you, the Big Dipper or the little one? In a moment, we'll talk more about Polaris, but let's quickly explore the other stars of the Small Bear. The next star in the bear's tail after Polaris is Yildun. Yildun is 172 light-years away and is actually moving toward us. It is a white star resembling a squashed sphere in shape. It is spinning so fast that it bulges along its equator. It is 327 million years old and is accompanied by a tiny companion star. Its name is Turkish, meaning star. After Yildun, the next star in Ursa Minor's tail is epsilon Ursae Minoris, which is approximately 347 light-years away. It is another one of those pairs of stars that orbit a point in space between them. We just call them epsilon Ursae Minoris A and epsilon Ursae Minoris B. Throwing these letters after the original name is a pretty common way to name these pairs when we find them. The first star of the body of the bear, or the star that forms the back of the bear, is Zeta Ursae Minoris. This star is a dwarf, is 380 light-years away, and is getting warmer. It is right on the cusp of expanding into a giant star. Continuing on that line, we find the nose of the bear. This is Kochab, the second brightest star in the constellation. Starting at about 4,500 years ago, many ancients, including the Egyptians, Chinese, and Arabs, saw this as their North Star, or as one of the North Stars. I think it is a great name for the nose of the bear because it kind of sounds like a sneeze. Kochab is a giant star. It is 130 times brighter than our sun, and is 130.9 light-years away. The next star, down from the nose of the bear, or its front paws, is Pherkad. Pherkad is 487 light-years away and is a supergiant, 1,100 times more luminous than our sun. The last star at the bear's back paws is Eta Ursae Minoris. It is pretty dim, has about the same amount of mass as our sun, is about 1 billion years old, and is only 97 light-years away. In our last episode in this series, we talked about the nymph Callisto, a follower of Artemis, and her son Arcas, the son of Zeus. But this isn't the only Greek legend associated with this pair of constellations. An alternative story takes us back to the birth of Zeus, the Greek god of the sky. His father, the Titan Kronos, was afraid that his own children would dethrone him, just like how he overthrew his father, Uranus. To prevent this, he would swallow his children whole right after their birth. Rhea, Zeus's mother, in order to save Zeus, wrapped a stone in baby's clothes just before Kronos snatched it up and swallowed it. Rhea was worried that Kronos would discover her trick, so she thought of a cunning scheme to protect Zeus. She met Oread nymphs named Amalthea and Cynosura, also called Ida and Adrasteia in other versions, who both agreed to protect the baby. Rhea told them how to keep him away from Kronos' gaze. The nymphs tied a rope to him and dangled him from a tree. Since Kronos ruled over the sky and the land, this kept Zeus from being seen. They hid him in a cave of Mount Ida and hired Corybants to dance, sing, and crash their spears against their shields to conceal the sounds of the baby crying. They retreated to hide on the island of Crete. The nymphs did all they could to nurture and nurse the baby, including turning into dogs, goats, and transforming into their favorite disguise, 2 bears. Later, when Zeus was grown, he returned to Kronos, freed his siblings from the Titan's belly, imprisoned Kronos in the depths of Tartarus, and took his place as the king of the gods on Mount Olympus. But he didn't forget the nymphs, who had nursed him and continued to wander the earth as bears. He decided to repay them with immortality, so he took their tails in each hand and swung them up into the sky, allowing them to live forever among the stars. This is why we still see the bears in the sky today, both with long tails that were stretched by the force of Zeus's mighty swing. Most historians agree that the Phoenicians were the first to see a pattern in the stars we call the Little Dipper. They called it the wagon, a small box, perhaps with wheels, and a long handle. Even in ancient times, this wagon was used by sailors to find north. Back then, Polaris wasn't the North Star, but this wagon was in about the right place in the sky. Thales of Miletus, a predecessor to Plato, one of the world's first scientists, and one of the 7 sages of Greece, famously called this constellation the Phoenician wagon. Later on, the Greeks would more commonly call it a dog, or the Phoenician bear. The Romans saw this constellation as 7 oxen, perhaps being herded by Boudes, the kite-shaped herdsman constellation, that we'll talk about later. In fact, the Latin word for north was named after this constellation, Septentrio, meaning 7 oxen. Polaris is the brightest of these 7 stars, but it actually only ranks 48th among our sky's brightest stars. It is 434 light-years away, which means that when you gaze at its light, you are seeing how it looked 434 years into the past. Polaris is 6 times larger than our Sun, and it isn't alone. 2 tiny stars rotate around it. These were first discovered by William Herschel, the scientist and astronomer who would later go on to discover a new planet, Uranus, named after the father of the Titans who fathered the gods in Greek mythology. Herschel also cataloged many cloudy objects called nebulae. It would be about 100 years before scientists realized that these clouds weren't just clouds. If you are near the equator of the Earth, Polaris may rise just above the horizon. If you are on the North Pole, then you will see this star straight above you. Most of us live about halfway between the North Pole and the equator, so we will see Polaris about halfway between the horizon and directly overhead. Since the star has a different location in the sky depending on your latitude, mariners were able to use it to also gauge their distance from the North Pole or the equator. Now, when I was younger, I understood that the stars at night looked like they slowly revolved around us as the Earth rotated on its axis. But then I was told that the North Star, Polaris, was always in the north. How could that be possible? Well, as it turns out, if you extend the imaginary axis of the Earth's rotation from the South Pole straight through our planet, through the North Pole, and then continue onward, you would nearly run straight into Polaris. It is 434 light-years directly above our North Pole and is only off by 0.7 of a degree. From our perspective in the Northern Hemisphere, all of the other northern constellations circle Polaris. It doesn't rise and set like other stars. Polaris is pretty close to our celestial North Pole, but that has not always been the case. The Earth spins like a top, and it wobbles like a top too. Before the Middle Ages, our North Pole pointed to a different star or pair of stars in the Little Dipper. Polaris will get even closer to our celestial North Pole until about the year 2100. After that, it will drift away. By the 41st century, it will come near Gamma Cephei in the Cephus constellation. Many astronomers over the ages knew Polaris by its more ancient names. Stella Maris, or the sea star, Phoenice, the needle, and my personal favorite, the lodestar. I wonder if this is related to the earliest names for magnets, lodestones. The ancients found that some strange rocks would stick together with an odd invisible force. When separated and individually placed in a bowl of water, their shards would always spin and point in one direction. These were the earliest compasses, and they pointed to the lodestar. Today, we understand this phenomenon well. Small magnets, when suspended in a medium like water or oil, align with the flow of the Earth's magnetic field. This flow now bends around the planet and meets back near our North Pole, but that will not always be the case. Here is a fun side note. When a new rock is being formed from lava or magma, it often has small metal shards in it. These shards act just like compass needles and also line up with the Earth's magnetic field. So when the rock cools, hardens, and solidifies, these tiny metallic needles freeze in place. They remain still even when the Earth's magnetic field flips and moves over time. Looking at the direction of the metallic pieces inside rocks is a technique that scientists use to know how old rocks are. This helps in the process of knowing exactly how old a fossil like a dinosaur bone really is. Polaris is a Cepheid variable, a variable star having a regular cycle of brightness with a frequency related to its luminosity. This property allows scientists to determine its distance from the Earth with extreme accuracy. Stars like these allowed Edwin Hubble to discover the chilling fact that the universe is expanding. By the way, it was also Hubble who looked closely at the nebulae once explored by William Herschel, and through the use of Cepheid variables, discovered that these weren't just dust clouds. They were completely different galaxies far away. The time has come for tonight's challenge. Rather than finding a deep sky object, your challenge is to spot a meteor shower that returns every year. It begins on December 17th and reaches its height on the 24th or 25th. These meteors are known as the Ursids and appear close to the nose of the bear, Kochab. So, if you are not busy with Christmas celebrations, why not step out into the snow and see if you can spot the Ursids fly past the nose of the polar bear cub, Ursa Minor. If you have enjoyed this conversation or have learned something from it, please leave a like, subscribe, and share it with other open-minded people. All of those small things really do make a big difference and help others find our group and our podcast. That is all I have for you today, but the conversation continues across social media and in the comment sections below. Do you agree with today's message? Am I mistaken about some detail? How can I better elaborate on this topic in the future? Feel free to share your perspective.